could you start off by telling me about your involvement in the ERMITAGE project?
Our role in the ERMITAGE project is to look at the links between the energy system and the climate system, future climate change. In fact, historically, decision makers were more interested in looking at the contribution of the energy sector to climate change, the emissions coming from the energy sector, for example, from power plants, from cars, from industries. This is what decision makers wanted to look at. But recently, in the last few years, the interest for looking at the impact of climate change on the energy system itself has been growing, and this is what we are looking at in ERMITAGE. So two types of questions we are looking at. First, what are the impacts of climate change on the energy system? For example, will the water be available in the future to produce electricity, hydroelectricity from dams? Will nuclear power plants have to be shut down if the temperature of the rivers increase too much during heat waves? Yeah. Or will we need new power plants to produce electricity for air conditioning if people use more air conditioning because of high temperature? So we will integrate these impacts of climate change in our analysis. And another type of question we want to look at, this is the trade-off. These are the linkages between the reductions of emissions from the energy sector and the adaptation or the impacts of climate change on the energy system. And to take the same examples as just before, if we think of hydroelectricity, we want to know if this is a good strategy to invest in hydroelectricity if in the future the water is not available to produce hydroelectricity. Or is there a way to reduce the use of air conditioning? Because the problem with air conditioning is that it needs electricity, and electricity might contribute to climate change itself by emitting greenhouse gases. So we want to look at these two types of questions in our contribution to the project, and for this we need two types of models: a climate model, which is provided by another partner of the project, and an energy model. This is what we provide in this project, and Amit will tell us a bit more about the energy model we are using.
So our model basically explores alternate configurations of the entire energy system. So it would take a certain set of energy service demands as input, as a target to be met. So for example, it would have a certain number of houses to heat, a certain number of passenger kilometers to drive, a certain number of million tons of steel to produce, and it will arrange technologies and fuels all through the system to do this in a manner that meets certain other targets of climate or sustainability or energy security or whatever. So it could be given a climate target and as an emission constraint or something else, which would be met in addition to meeting all these other demands that it is meant to meet.
So you set the model with a target figure that you want it to reach, and it twiddles around with the other parameters in order to reach that target. Is that right?
Yes, exactly. It would make decisions in the end use sectors, in the transformation. So it would choose a good way of producing electricity. It would choose a good way of driving cars, a good way of making steel, all together, and it has to be consistent because the electricity that is needed by cars also has to be produced. So that is why it's called a systems model. The most important value it brings is that it makes sure that the decisions across sectors are internally consistent. So the biofuels that are being used in the cars are being produced, and the land use implications of that bio production is also all seen at the same time. You don't have to do different analysis for all these different considerations.
So once the model's up and running and it's producing its results, what are you hoping the impact of those results will be?
One important result we expect from our analysis is the definition of what we could call climate-proofed low-carbon strategies, meaning energy strategies which don't emit a lot of greenhouse gases and which are not vulnerable to future climate change. So this is the main output we expect from our analysis. So, ideas of future energy policies that the decision makers could use to define their policies.
Is that your hope as well?
Well, the first best use of our models is to produce an ideal system configuration. You know, a least cost, I mean, something that is the best possible way of meeting a certain target. So that is actually setting a target for the policymakers. So, for example, if there is a very strong carbon reduction target, then the model would choose a configuration that minimizes cost. So it may say that it may choose a mix of nuclear versus wind versus solar, depending on the usage pattern, depending on the local potentials and so on. So that would set a target for the policymakers, that this is how you should aim your subsidies and feed-in tariffs and so on, because this is the mix that would actually minimize the system cost.
How do you ensure that the model is robust?
The most important way of ensuring robustness is to run many different scenarios. You know, because you just change assumptions and you run it against many possible futures, and then you see which decisions have stayed the same in the near term, especially because you always decide for the next 5-10 years. The model may be very variable 30 years from now, but you're not making decisions 30 years from now. So they only have implications. So the movement in the next 5 or 10 years is relatively much smaller. And that is what the policymakers should be able to use.
I'm going to ask you another question. I'll ask you both in turn, starting with Amit. Given that we have global environmental change, regarding our future, are you a pessimist or an optimist?
I am always an optimist. I believe that, change is the only thing that is constant in this world. So it is a part of evolution. It is just that some things are being determined and prioritized differently. But this is not any calamity, or this is just a guidance to our evolution that is happening anyway. And you see, when we were using fossil fuels, we actually didn't have a plan. So we are still using it. I mean, we are digging things out of the earth and burning it, things that have taken millions of years to be made in that form. So there's really no plan. I mean, it's not a question of if, it's a question of when. We had to stop using it at some point. Just like stones, stones didn't end the Stone Age. I firmly believe that oil will never run out. I mean, we'll find better things to replace it, and it's a part of evolution. So I don't see it as any calamity or any problem.
Well, that is optimistic. What about you, pessimist or optimist?
I'm also optimist in the sense that I strongly believe that decision makers, when they have information to make decisions, are able to make good decisions, meaning good decisions for all of us now and in the future. And this is where we might have a role to play. This is to make analysis, to make studies, to provide them solutions and to show them that, yes, this is possible. We can reduce emissions, we can reduce our impact on climate change, and we have to show them that there are solutions for this.